2005. We have several patents pending. We actually create high power LEDs, and then we have just regular task light LEDs. So I brought two examples of light fixtures today, just so we can kind of, for this application, there's a possibility for this application, but it can also be kind of viewed as possibilities for other applications. So this is one product, and you guys will get a chance to actually come up and look at it later and touch it and feel it. But this is a panel. So this is an LED panel, and it's an edge lit. So the LEDs are all the way around this panel, and they shoot inwards. This is a special acrylic that is laser etched. And in this special acrylic material, it's actually laser etched oval, like little pyramids. And the pyramids come out like this. So what happens is when the light hits it, it hits that pyramid and emits the light out. Okay, so all the light comes out of here. This will actually create close to 5,500 lumens for this, and it only burns 55 watts of energy. So it's really a really efficient source, but you're going to see how even the light source is. It has a special diffuser on here that makes it so it diffuses it into a complete even light. You don't see any spotting, hot spots or dark spots. The whole fixture lights up. This is made so it can be suspended, or it can drop into a suspended ceiling or T-bar ceiling. So the actual thickness of it is less than 5/8 of an inch. So it's very, very thin, low profile. So we have it in a lot of applications. Most of the applications right now are for suspended ceilings. So we do actually have it, so it can be suspended independently, and we actually have a different version that it goes into freezer applications. So we do a lot of cold storage and freezer applications. This is one of the uses. So what I'm basically going to do is light this up here in a second. Oh, it is. Okay. And it is one.
Chris. Chris, what's life expectancy on that?
Okay. So to give you an idea on the amount of light we need to put out, this is at full power, and it's actually probably a little less than full power, but you can see in this corner, that's the reason we put this in the dark corner, right? So we can see how much light, one panel, 55 watts, is going to light up this area. So it's an amazing source of light, but you can see totally even. This is color temperature at 5,500 Kelvin. So what we do is we try to match daylight with this. We do have another color temperature. We actually brought with us is just a touch over 4,000 Kelvin. More of a neutral color is what they call it in the industry. We do not make the 3,000 Kelvin because we basically don't recommend it. It's more of like a residential, warm glow thing, and it's not a very efficient light source. 3,000 is just, it's for more ambient or just, like the romantic glow or whatever. So we do mainly commercial and industrial. We don't do, we don't actually do a residential version. One thing about these light fixtures, they are fully controllable. So we have our own system that is actually controlled through the computer, and Chris is actually dimming the unit now. We can dim this down to 1%. A lot of companies can't even figure out how to dim it down below 10%, normally just different sorts of ways, but we have over 250 stages of dimming for the fixture. In doing that, we utilize that program to take advantage of daylight. So if we work with daylight systems or skylight or windows or ClearScore or whatever it is, the natural source of daylight, we can dim this down according to the amount of daylight. We can program the light fixtures in the program to be so many foot candles in the space. And if there's enough daylight, that light fixture will be off. If there's not quite enough, it'll gradually come up. And it automatically adjusts according to how many foot candles you program it to be. So it doesn't matter, you have to go change, you don't have to turn it off. If there's enough daylight, it's also going to be on at 20 foot candles or 50 foot candles. And we have facilities where we light it up and we give them anywhere from 20 foot candles to 200 foot candles. So this source is good, and we don't use this any higher than about probably 17, maybe 20 feet would be the maximum because of the amount of light output. When we go up over that, we use this fixture. This is we have a version of this is a low bay and a high bay. This fixture, and I'll explain it a little bit more in just a minute. I'm going to dim that down to like 1%. So that's 1%. So we can just that easily bring it down to whatever level we need to be. This is just a web-based program that can be controlled with any PCs. You also have a Mac version, people that like Mac. So that's part of the program system. But down the road, we're going to have another system that'll make it work so you have an app for an iPhone and Android. So you can actually control the lights right off of your smartphone. So anyway, that's actually the panel. The panels come in a 2x2 standard like this, or 1 foot by 4 foot size. So that's the 2 standard sizes. We really don't do much more than that because that's the only mark we're trying to go after. Any questions on that so far?
What's the cover?
Sorry? What is the cover? Oh, it covers, well, it just depends on how many foot candles. So in a room, basically, if you had a room and you put in a regular 2x4 fluorescent with 3 lamps, you could replace 1 for 1 and it have the same amount of coverage. So it'll actually replace them. Yes. 2x2 what?
Can type of goes in the T-bar.
Like a 2x2 fluorescent fixture. The cost difference between a 2x2 or even a 2x4, basically, it's probably about double the cost, which isn't bad when you actually, throw in the savings. Fluorescents, you can't dim them unless you throw in a really expensive balance. And fluorescents don't like to be dimmed. Basically, they like to be full on. If you dim them, it shortens the life. And fluorescents don't like to get turned on and off. Basically, it's the only fixture that is a light source is LED, likes to get turned on and off. So the more you can turn it on and off, it just makes it last longer. So it's more of a thing where we love to get turned on and off. And it also, the way that we dim it is a pulse width. We don't do any dimming where we don't change the voltage on the incoming AC. We don't change the voltage on the outgoing DC. We don't have potentiometers. We basically have a pulse width modulation, which is the best way to efficiently dim an LED down to 1% and actually make it last longer. We elongate the light. Yeah.
So in a normal day with it on, how long would it last? Like what's the life expectancy of it?
Well, in a situation for, let's say, if we had this in a space and you were doing daylighting or not daylighting? Daylighting. Okay, so if you did daylighting on this, it would be constantly changing up and down. The fixture would last probably between 15 and 20 years. Yeah, it's just, I mean, it's going to last an extraordinary amount of time. There's a new certification lifetime measurement called TM21, and it's put out by the Department of Energy for measuring elongation or lifetime of a light fixture. So it all is based on how long you have it on, what the power you rated it, and the coolness. So the longevity of an LED is based on current for correct controlling it with power and how cool you keep it. Those two things. So if you control that, I have light fixtures that go into cold storage and freezers that will last well over 400,000 hours. Because it's like there's no stress to it. It loves the cold. Turn me off and on all the time in cold. I love it. No other light source loves cold. LEDs love cold. So they'll last a really long time. I don't ever say forever.
I have a question.
A lot longer than I'll be around.
I have a question.
Yeah.
In terms of like initial cost, weighing out fluorescents like T5s or T8s between LEDs and the solar tubing, what would you think would be an economical choice in, let's say, 5 years' time?
In a 5-year time? Between fluorescents and LEDs?
What's the payback?
The payback between fluorescent and LED, if you use daylighting, give me the scenario. Basically, so the scenario will be, will enter so are you have daylighting? Are you using any solar? Or no solar?
There's a let's say yes.
Okay. So the options are you can use solar with the LEDs and you can't with fluorescents unless you take. So one thing nice about the actual LEDs is they work off of DC voltage, right? So our fixture it can't work directly off the DC bus from solar. You guys are familiar, I know, with solar, and it's a crucial thing. It's something where we don't have to take the DC voltage from solar and transform it up to AC voltage, and then we transform it back down. So you lose a lot of that efficiency. We just cut out those two processes, and we can actually take the DC voltage, and then we can put it right into the LED. So if you have a solar, it's going to make it last really long. I mean, you can actually not even use a lot of, depending on if you have solar and if you have battery backup. If you just have solar, it's just going to be used when the solar is, and then that depends on time of day and year, time of year. So there's just, you can actually go to a calculator that's on the web, and it's on the, go to like a Bristolite, and it'll actually show the calculator for when the best times of the sun and when it's most profitable.
Right.
If you compare it with just a fluorescent, your payback is about 50% more efficient than a fluorescent. Okay, fluorescents are pretty efficient, but it's the savings, the cost, the actual energy savings of about 50%. Okay, where it really gets into the pluses is over the time. We said over a 5-year period. Basically, it's the maintenance, because we'll last more than 10 times the life of a fluorescent. So you're going to have to replace that fluorescent 10 times in the life of this LED. So you're going to have a lot of fluorescent tubes, you know, you got to take and put in the dump,
right,
or hopefully not the dump. And so they have to go through recycling, but you got to pay for it. Another extent, and then you also have to pay for the ballast too.
Right.
Because the ballast is burning. Question?
Just doing the math real quick, the 400,000 hours running 24 hours a day is a little over 45 years.
Yeah, that's only in a freezer.
Okay.
I don't want anybody to think I said that. Our fixtures last 400,000 hours. Only in a freezer. We do freezers. We do cold storage worldwide. So we do have those applications. But an average for ambient, and you're using daylight harvesting, it'll last about 150,000 hours. That'll be the lifetime of the fixture in a regular roof.
Can you tell us a little bit about the driver?
Yes, so what we did with our driver, we actually used an off-the-shelf power supply, which is through Meanwell. It's, we found in testing, is one of the best in efficiency, and just they've been around for a long time, they have a 5-year warranty, and it's like all of the stuff that we need to have high efficiency for ours. We developed our own driver. In our driver, we've got over 96% efficiency rating. So actually, our fixture is over 95% efficiency because of that, and it's certified. So in our driver, we control each circuit separately and give it exactly the amount of amperage that is needed and exactly the amount of voltage. So that's what we actually control.
That's good. You want to see all these
It's a
lights up here?
24-volt system, but then it's fine-tuned even further for our driver, which is just a little less than 24 volt. And we drive the LEDs are actually driven at 2.1 amps or 2100 milliamps. Yeah.
40 bucks a pop.
How much does it sell for?
Yeah.
This is about 250. Yeah.
Probably buying probably full.
And then it's double for the 1x4.
But then
The 1x4 is the same. Yeah, it's exactly the same configuration in LEDs and the same square footage. It's just elongated. So in a 1x4, the LEDs are on both sides, and at 2x2, they're all the way around. So that way, you don't have any dark area. So it gives a really good emission and even lighting. Any other questions? Yeah. Yes. Yeah, this is every unit, well, not every unit. Basically, we can control 8 units on one driver. So we can actually control, so we can do 1, or we can do 2, 4, up to 8 units on one driver.
These units have remote drivers. Those are drivers.
This actually, that's correct. This has a remote driver because these applications, you never know if you want 1 or you want 50, right? So they're configured by each one, and so it does have a remote driver. This actually has the power supply and the driver built in. And I'll explain about this next.
How many drivers can you control with the software?
How many?
We haven't.
It's unlimited, actually. There's no limit on the amount of drivers. We can do 1,000 fixtures easily, and we can go and do the next 1,000. So it doesn't. There's no limit on the amount of drivers we can control.
Would it be something different?
Yeah.
Well, this is a sample of what they have. They also have a sun tube, so you can be out of deal with mud. They don't have a working model. They don't have a model.
We have an AC power supply here.
So this is different.
We're working on power supply right now, which is
Well, you can
AC.
see this kind of
But
panel
we have,
could be
what we
directly
do is we
control these
keep it
lights.
separate, so we have a power supply and a
that
DC
would be-
driver.
It would be brighter.
So if we
And
want
more
it,
energy
if we
efficient.
want it to work off
And
DC, we just
Our grandchildren
don't
are going
use
to put them in
the
these
power
chambers.
supply.
Wait, how many
So we can do either.
in this environment?
24/7 gives 17 and a half years.
Not much. And we're rated over 95% efficient with the AC power supply.
And then we only run 9 months a year.
So we're even more efficient with a DC.
So I'm thinking.
To give you an idea, we're probably at about 98% without the power supply. So it's only about 3%, but
Okay.
By then, the building's going to be.
it's a little bit. We look at every single percentage, even down to, in this fixture, we use a glass that's 96% efficient. Most people don't know glass. You lose light output when it goes through clear glass. Regular glass, you lose 15% of your light if you use regular clear. So we're one of the only company with LEDs that actually uses this kind of glass. that I know. Any other questions on the panel? And then I'm going to go ahead and go to the high bands. No? Okay. We don't want to shine it at you because this one's really bright. Okay, go ahead and bring this down to 20%. Okay, so this unit it does. Okay, so this fixture, we have it as we call it a low bay or a high bay, and depending on the applications, we developed it, we manufacture it. This is all manufactured in America. Basically, this is assembled in Santa Cruz. So we have our own assembly facility in Santa Cruz. All of our extrusions are made in Portland, Oregon. All the rest is made in California. So this will always be made in America. One thing about this unit is it's a modular unit. And can you turn it off just for a second? I'm going to show you this. Kind of get an idea. So inside here, there's a hub, and in this hub, it's got several slots in this hub. These are arms that comes off of this hub, and then they go out to the outer hubs, which hold the lights. The inside hub can also hold an additional light, or it can hold an occupancy sensor. So depending on what we want to put on this light, it can actually use any of those combinations. This hub will handle 2 arms, 3 arms, 4 arms, up to 8 arms. So this fixture actually can have 8 of these arms coming out, with one in the middle, which is a 9 light, which puts out over 70,000 lumens. We actually can light from 100 feet in the air. And there's not one of our competitors in the world that can actually do that, that we know of. And if you hear of them, let me know. So anyway, we actually have this installed at 80 feet in the air. We have it installed at the Tesla Motors facility in Fremont at 60 feet in the air. So we have several areas that we've done. And so we're at 60 feet, we're at 20 feet, we're at 40 feet, we're at 17 feet. We're 45 feet in cold storage, so all these different applications. This is what we call a modular fixture. And a modular fixture, we have these hubs and we have these arms. Okay? So on the end of this arm is a hub, and underneath this is we call a hub cap that has an option of 5, 10, 15, 20, 25 degree tilts for this light fixture. You can see these are tilted out. They're not straight, so don't go straight down. We actually do that. And then inside of this hubcap, there's several threaded holes. So we can clock it 180 degrees either way. So we can change it every 22.5 degrees. So basically, we can build over 500 fixtures with just these parts. Same parts. My kids call them transformers. You can literally take it apart and put it together in a totally different shape. Okay, so what I explained was we have hubs and arms. So what if we took a hub and an arm and we put in a hub and an arm and a hub and an arm, and we made it in a zigzag. We made it in a square. We made it in an octagon. Basically, we built fixtures that look like, you know, the space station. It's pretty amazing what you can do, and the light output you can do it. This here is a standard light. With 4 of these modules, it'll replace a 400-watt metal halide. And we burn 208 watts of energy at full power. That'll give you an idea. It is fully programmable, and it's kind of hard to see. There's a little antenna right here, so we can talk to it remotely. Each fixture is a smart light. So each fixture is programmable to be at any light level we tell it to be. We can tell it to be grouped at these 2 fixtures or these 200 fixtures are in one group and control them separately as one group. We can tell them,
Yeah.
okay, you guys come on with the daylight,
they would
I mean,
need
you go
to,
through the daylighting. These ones over here are gonna be on occupancy. They can be controlled individually in occupancy or in groups on occupancy. It could be made as a master or slave unit. This could be a master that could control,
This could,
you know,
yeah, if
2 other
people are
lights
interested in
or
technology,
200
yeah,
lights,
yeah, guys are interested,
according to when it comes on. It can be controlled according to an event, so you could actually tell it what time of day. If you want these things to come on at 6 o'clock in the morning at 50%, and then at 9, you want it to come on at 100%. At noon, you want it to go off. At 1 o'clock, you want it to go back on at 50%. Whatever you want it to do, you just tell it to do, and it'll go through its whole program. Once you upload the program, it does its own. It does the whole thing. So basically, it's a smart system.
These are only
It
two lights it's showing,
can
so it's talk about the technology.
be
and the software,
controlled
so
with any space to light in any
5
way.
minutes.
The versatility of how the fixture is shaped with all the modular units is, we take a facility, doesn't matter what size the facility is, we take the length of the walls, the width of the walls, and the height of the, so we take the cubic dimensions of a space. We say, and they say, we have, you know, it's 35 feet high, we need 50-foot candles in that space. We build this light fixture in the photometric program. So we physically build the perfect light for that application in the photometric program, and then we do a photometric layout, and we can make the light totally even, better even lighting than any other source that they've ever had, or they can even do with any other competitors. So, and then we give them that, that's the proposal, and then that light fixture is built according to that work order. So it's a totally versatile light on what you want to do. We have facilities that, let's say for instance, we're going to light this space. It would actually be mounted up in the ceilings. And it could be mounted up in the ceiling. You could have panels mounted in the ceiling. This is a different application room because you have a vaulted ceiling. Right now you have recessed cans in the ceiling, which are round, and what are they? Metal halides? Yeah, it looks like a metal halide, some type of halogen. You can tell the different color shift of the different lights. It's definitely some type of halogen source because there are different color temperatures because of wear. After certain times, usually about 50%, you'll lose about 50% of the light output. So you can see some are warmer, some are cooler, some are a little purplish. So this application, is this a bed, is this open on the top of them? It has to be open if it has a bed.
Yeah, there's a gap between here and the actual roof.
So there's open from there to the ceiling. So it actually could have the square light. So we have another application that we use for food processing and bar ceilings where it's actually a square light and it's an LED. That's another possibility for here. And then it's more of a diffuse lens. It's a 2-foot by 2-foot. So that's a possibility. This is a little bit different area. So
You still can use the high bay.
you could use the high base.
How many high bays would you need?
In this area, 4.
4?
You wouldn't need any more than 4. Yeah. Can you come a little closer? I can't quite hear you.
There's a lot of space between here and the roof in terms of like solar tubing along with this LED. What you only need like 4 of these units you're talking about, or are you talking about with the
This high bay light, you could use 4 units.
with the new unit that's coming out commercially?
If we did the other unit, it would probably take. How many foot candles do you